Hello. So today is April 22nd, 2025. This is SIG Node weekly meeting. Welcome, everybody. We have few agenda items, and Ajay goes first. Take it away.
Thanks, Sergey. So hope everyone is able to see my screen like presentation here.
Yep.
Right. Okay. So today I want to propose a new feature concept called node readiness gates, aimed at addressing some long-standing challenges around like ensuring nodes are truly ready for workloads beyond the basic kubelet health checks. This is based on ongoing discussions on multiple issues across Kubernetes and other layers on top. But the need here it's addressing is providing a robust Kubernetes native way in Node API to handle node initialization dependencies. I shared the provisional kept draft like in the chat for further discussions to get this idea across. The problem is that we all know that when a node joins a cluster, kubelet reports ready equal to true state. It doesn't necessarily mean the node is fully equipped to run the complex application workloads immediately. Um, this is the core problem. The basic ready condition is essential, but it is often insufficient to represent the workload readiness in the node. This proposal is not to replace it, but provide additional write signals for declaratively establishing a node to be declaratively establishing the node readiness. Many applications rely on underlying node level dependencies being fully ready. For example, it's a service mesh like STO that would need prior conditions to be satisfied, like CNI is installed, DNS ready, and other things that need to be active beyond just checking a config file is present for CNI, or storage drivers being ready before the stateful workloads can be deployed on top, or it could be just observability agents we needed for collecting metrics from the start of the workloads, or security policies that need to be enforced on an enterprise before business pods or teams owning applications can layer on top. It can be many. So that's a whole uh, like picture, the gap that this proposal intends to address. Scheduling pods before these initial dependencies are met is a common source of failures. It's because like network is unavailable until the pod network is set up or the storage is not ready yet. Or it could be that the metrics are missing during critical startup phases that need to be ensured before the pods start, or improper security postures, etc. So these are the pain points that need to be addressed. I also added a reference here that has been like a long-standing issue or discussions on why where this gap is felt and the need for better semantic readiness. And there are workarounds today. The most common way is to apply a custom taint during node initialization and deploying separate controllers to manage the removal of that taint once the prerequisites are met. While this can work, it has like many drawbacks like, that I tried to capture here. And also having bespoke solutions required by every third party different third party agents make it difficult to standardize this. There is no like cube native way like node giving an API or like having a way to represent readiness of the component on top. So want to go over the pain points um, one by one. First, it's harder to bring this within the node because it's for the component because like the privileges are high. It needs like nodes patch for spec update, which is harder to open up, a risky security concern uh, for a wider RBAC for different third party agents running inside the node. However, if it is a status update, it's a sub resource and it explicitly matches health reporting semantic. Second, another thing I wanted to bring attention is visibility focus. So the debuggability is terrible. If a node stays tainted, it's hard to know for the application teams why it is tainted, like what underlying condition failed, or the taint controller failed or doesn't convey the full reasons correctly. Like I already discussed, like maintaining custom controllers is complex, especially when there is like multiple layers on top, and controller for exclusively taint management is complex to build for enterprises, and it is often reinvented. Needs to have robust monitoring, state management, and clear API interaction. There is no standardized way in API to handle this rightly. Another thing is it's fragile. Like a taint state can be overwritten. It's susceptible to external state resets. For example, like a node maintenance script or like a node pool remanagement, like settings reprovisioning could sometimes inadvertently like clear the taints or reapply the taints. Having taints to express both uh, necessity or a desired state and also observed state is not the right way to do it. A semantic clarity would be to have the observations go into the status, not onto the spec, which is the desired state for the node. That is clearly the gap that node readiness gate intends to fill. And the proposal is to have node readiness gates to provide a standardized Kubernetes native solution. The idea is simple, allowing administrators to declaratively specify the prerequisites for the node directly in the spec. There will be a new field, like readiness gates on the node spec, which should take certain condition types, or these are just strings that would be the checks that the node must pass before declaring itself ready. And the components that are responsible for these checks individually, like Istio or CNI or monitoring agents, would report their status directly on the status on the as conditions on the node object. This is crucially, it is lower privilege with a node status patch than a node spec patch. And the check would itself be handled as a scheduler side plugin. It would check whether all the gates listed are satisfied before considering the node as schedulable. Now, this solves many of the readiness guarantees. A node would be fully ready, declare it is open to accept workloads, and then scheduler assigns the workloads on it. There is, however, one problem that could additionally be required solved. Is if a node restart, the workloads don't get like it doesn't lack it lacks the protection because the scheduler doesn't get involved anymore. This bootstrap problem could further be solved additionally by having a pod admission check for specific core guarantees. For example, in this case, I have presented for network readiness, where there will be standard prefixes like network Kubernetes.io, which should represent that like this is a core network readiness check that needs to be met before the node can be considered network ready. Kubelet will use these special readiness gates or prefixes to establish a well-known condition or well-defined condition called network ready that will be managed by Kubelet. Kubelet will check for this state before starting host network false pods, like whatever that would need pod network before starting on the node. This would be an additional enhancement that would need to fulfill also the node restartability or recoverability use cases. These are the two proposals of the API that I intend to show here. And this is how the API will look like. There will be kubelet configuration that would take node readiness gates that the node need to satisfy before considering as workload ready. Sample would be on agent ready or a patch that need to be fulfilled or some driver installation or network condition as we discussed. Cilium is ready before the pod network could be started. This is how an admin would declare that, okay, these are the things I want to be met on the node before it can take the workloads. And kubelet would create this node spec, including the readiness gates. It would declare, okay, these are the conditions I'm trying to I'm expecting to meet. And the scheduler would look for these readiness gates being satisfied, and it would, once it is met, it would start scheduling the nodes. At the right side, I have captured how a status would look like once each conditions are patched. It would clearly capture um, explicit states on whether each conditions are met, with including reason. For a failure, it would be like a degraded failure and what is the error message, or it expresses richer observability status than just binary taint not present or not. It captures more in-depth developability information as well. That's the high-level idea. I think I could take a checkpoint here for feedback before discussing the design or further. Are there any questions I could take now? Or
Thanks, Ajay. So I think, have we given thought to how we'll handle so right now we have just the network and the container runtime, right? Imagine like we have 7, 8 entities that we are depending on for readiness.
Mhm.
And how do we handle the life cycle upgrades of those entities? Is it going to cause too many periods of time when nodes are not available? Uh, Say a security agent needs to be upgraded frequently. Is it going to cause more disruptions to the cluster in terms of readiness for workloads? Because usually your kubelet and network won't change. Your runtime and your networking won't change in a Y stream, but your security agents and other pieces could be upgraded at a more frequent basis.
I see it. So what you're suggesting is that, like, for example, a node upgrade, for example, a component upgrade, how the readiness gates would
Yeah,
act there. Is that the right question? Okay.
yeah.
So comparing it to the present condition here, right? If you expect the new pods should not be created until the security agent is complete, I think that the behavior doesn't change. It's just that the mechanism on how this would be handled would change. Um, the condition could be patched by the security agent deployer or like a controller outside that sets the condition to be removed on the node. That would set like, okay, no new parts to be scheduled here until this agent is ready. Then um, my point here is that the mechanisms to control the upgrade chain, but this shouldn't create an inadvertent delay for upgrade time.
Great. Thanks. I'll do Sergey.
Yeah, it's a little bit build up on what Murnal asking, but also different angle of it. Like we, I really like the direction. We need to have some readiness, readiness indicator so we can run some
Mhm.
custom workloads. It's a great idea. Like we need to solve this problem. So
Mhm.
we really need to clarify semantic of it. Like what does it mean? Like does it mean like what does a not ready because of condition mean? Is it indicate that you cannot schedule or you cannot run a pod? Like for instance, you said that restart will be handled, and you looked at restart from a perspective of cleaning up readiness states, but doesn't mean that all the pods will be automatically removed from from a node, or like they will fail admission and then need to be rescheduled. Um, if agent is disappeared, do you want to like evict all the nodes immediately because they cannot run? All the semantic is need to be clearly thought about, and it may be that different tools will need to have a different semantic. Like I don't want to evict pods because there is no Datadog, but I just cannot run it because there is no network.
I completely agree. I think that like the semantic difference that I want to clearly capture here is that readiness gate is clearly that like it's a prerequisite satisfaction. It shouldn't evict pods. It's mostly for like a entry control for the workloads at the node. It's giving that right signal for scheduler or for example auto scaler on like, hey, this node is ready for further workload handling, not for existing workloads on the node. Like, removing or evicting is already given by other tooling. For example, taints to serve the purpose. You could explicitly say, hey, okay, like my intent is I don't want to execute this if these conditions are observed at the node, like exclude this. for this specific cases. For example, like, this is owned by certain team, and adding a taint would exclude other teams from accessing it. Or having a sample taint, like it's a GPU node, so other workloads don't want to run on it. I think like that specifically, I mean, that continues to fit better for taint and not node readiness gate. I agree that like we need to clearly establish the semantic differences between these two mechanisms. The node readiness gate aims to address only the problem of the prerequisite satisfaction and giving like richer conditions or like statuses for different components to observe and maybe in the future have better sequence control on the initialization of bootstrap of the node. That's how I see this fits in. Does that answer your question?
Antonio?
Okay. So to answer on the network thing, Patel, we already have this network ready condition that comes from the container runtime, and we have a lot of problems. We have a lot of projects that are deadlocked on that condition, and that's not enough. We really need a mechanism like this to be able to represent node readiness based on the different components. Networking is no longer a CNI file, it's a bunch of multiple projects, and we need to be able to represent this network readiness. I agree with all of you with the semantics. I really think that it's easy to drift or deviate from the original plan, but from the networking perspective, what I expect is to have something similar to network readiness that we have now, that the current condition, but allows us to integrate all these multiple projects, service mesh, proxies, CNIs, DNS components, in being able to signal the the workloads that the network is ready for them to run.
Thank you, Antonio. Do you have the questions?
Yeah, I'm not sure I'm saying anything all that different than what others said, but I think that readiness, just saying readiness is like too broad. Right? You're ready for something, and you're ready, and the what you're ready for, the different workloads. You get a blending of those semantics between taints and readiness here, and I'm not sure how to handle it. But I think this is what, like, the idea of network readiness is one thing, right? But the idea of ready for applications, but it might depend on what that application is. If it's a application that needs GPUs, then you need the GPU drivers to be installed, and so you need that readiness flag to be set. But if it's an application that doesn't need GPUs, you don't need that. And I'm not sure yet we have taints and tolerations. We're having another discussion around capabilities and things that are potentially more static, like kubelet feature gate flags and presence of GPU. Like, I think there's like at least one more discussion about a similar and related topic, and we need to make sure we get the semantics right. I feel like we're circling around similar problems and we haven't quite figured it out yet. So I like where this is going, and I like the idea of multiple readiness gates, or multiple readiness conditions, which would be calculated from a set of conditions. So it's like summarizing conditions, I guess you could say. But I'm just not sure yet how you express it in the pod, that you have a dependency on that, and how that, if we do add that, how that differs from taints, and whether it differs enough from taints and toleration. So yeah, that's just some comments, I guess.
Thanks so much, John. John, I hear you. I think that like that's important, and I thought about it, and it's been discussed with the folks internally on this as well. I see that as a further layering that is important. There are two intent here that we need to clearly like separate. First is node expressing itself is ready. That's the node readiness case intent to solve. The second, how this would evolve is that pods declaring node readiness requirements. Like, this is what I consider node to be okay to like run me, right? That's like a declarative point from the pod perspective, workload perspective on, hey, this is what I would need on the node. I think that should come as a follow-up to node readiness case. We should definitely like think about this problem and make sure like we align with the, like I said, the multiple projects that have been discussing for like scheduling Gate. I think that like the capabilities is another one, which should clearly integrate with the node readiness kits to make sure that like we have that better control at the workload level, or the teams to have that application readiness on the node.
I'll just say one more thing that, I mean, I think the reason we haven't done this in the past is that in a proper distributed system, you don't need sequencing, right? Like you should wait for things to reach the state that they need, and if they fail, I mean, I guess we're just trying to make it a little more explicit so that you still don't have sequencing, but we have conditions rather than just like failures, and maybe that's better. But I don't know, just to put a another spin on it, are we trying to solve a problem that we should be solving a different way through just retries? Maybe Antonio, since he's saying we have all these problems, is going to tell me no, the retries aren't good enough. And that's fine. I just want to raise that as a consideration.
Maybe Antonio, can you try to answer that retry?
Yeah,
Also want to hear that answer too.
The problem is that the Kubernetes deal with this simple network model with a CNI plugin, and now we have a bunch of projects, right? And DRA is adding more to the networking, right? And all these pods, networking is simple. If you have a host network pod that is not host network, you need networking, right? You need an interface, you need DNS, you need proxy, you need all these things. So in our case, we were trying different things, and it didn't work. I asked CNI maintainer to add CNI status, and it was complicated to share this signal to the kubelet, and this the network is being more fragmented. You have the problem between service meshes and CNI plugins. So we need something for network components to be able to signal if they are ready, and CNI falls too short. So it's an integration problem of components. It's not a problem of installation and retrying, because there are multiple things that eventually need to be consistent.
Right, but I guess what I'm asking is, I think it was Sergey Mornal, one of the brought up, like, right, like anything can fail at any time. Can readiness go backwards? I think maybe as somebody in the chat, like, right, and in which case, right, we need to retry anyway. So are we? I mean, I'm being a little bit devil advocate here because I actually like the readiness idea, but I'm just wondering, like, are we getting lost in like the problem at hand rather than going back to like it's an eventually consistent system? Eventually it'll work. You know, are we saying we need to know how long eventually is? Is that the issue? Like,
that's the cap. I cannot answer that. I have an idea of what is required. You know, we need to consolidate this. We need to have several components that need to agree on something to work. This is a good next step, and I think that the cap will sort out all these questions. But I have the same questions that you, Johnny. I know that we are going to find edges, but current state is in working on this is unsustainable.
Okay, my turn. So I like this readiness direction at least, and also I do think we need to have this mechanism. Actually, John, we tried internally before, but just don't have the resource to really finish the work for the node ready, like the beyond today's open source node ready. But I do have concern. This mechanism is so powerful, and this is why John's concern, and also it is also my concern. I worry about. Okay, this is one thing. So eventually, if this is right, we hope like the scheduler can take into consideration, same as the node capability, right? So we are going to. So then, and Age and I discuss some potential follow up how to indicate the pod. Because my concern it is once we have this kind of things and the scheduler blind respect this kind of things as the total everything restart. A lot of pods don't have the dependency on those new readiness gateway and the gate, and also then they end up to slow their scheduling, right? So like increase of the scheduling latency, increase about that pod startup latency. That's unnecessary. That's the concern. But one other thing is, if we take this node network readiness, and inside that one, you can see that actually the current example I saw that slide already have like the 3 different of the network perspective. And a lot of it is actually outside of the node, could be, right? Some is node and some maybe even go crazy. Like the Antonio, there's the one senior readiness in the past, right? Before your re-architecture change something, it is rely on the remote control plane and to issue something and to the node. If we rely on those kind of things, that could be like the forever deadlock there. So I just worry about I think the direction is right, but I do worry about we might be abusively to using this, utilize this mechanic. Yeah, so that's kind of things, because obviously on the network side, there's some like the outside of the node. This is also different when this proposal come to me, then I think about why. First time I'm thinking about why not do the node capability. But then I realize actually there's something we maybe want network to set in their control plan. And in that cases, there's the mutual dependency to each other.
Thanks, Don, and everyone for the discussion. So I hear the concern that like if the node is to wait for an external entity to have like a signal, it could be potentially be waiting forever, like possibly on a deadlock. I think that like one way this could be addressed is to have like a timeout on like, but is to go into a weaker guarantee than a stronger guarantee on whether the node is actually ready or it was overridden. One aspect I thought about was that like the status condition could be like weaker, like having a timeout until all the readiness gates are met. Otherwise, it would override and explicitly capturing that the readiness gates are not met, but it's resumed. That's one way to handle that. I think we can discuss this further on the cap on what are the gaps that need to be on how this could be addressed. And another thing I think that like concerns I hear is that the flapping. What if the conditions are like updated frequently? I think that like that is a valid concern. The controller agent logic should be like it's crucial. It's a primary responsibility for the agent to stand the condition. I think that like we should probably like think further on like how successive failure checks or like like having thresholds to have the condition to set like, to a degraded or failure state, or like having like some kind of a timeout or backup to make sure that like this abusing could be reduced. I think that like these two valid concerns I take away and explore further. And also, as Don said, on the pod level integrations, I think like we should further explore at the cap. I could take these 3 as follow up, and I'm happy to like address this and discuss further to bring the claps closer. If there are any other questions, I could go further on the design. Like I see this primarily at like 2 level. One is at the scheduling side, that the right model where it fits in is the scheduling filter. Like we have the scheduling framework in Kubernetes that have like a plugin model where like a specific scheduling control, in this case like node readiness, could be optional, or it could be like plugged in without polluting other code spaces or components. So this could be just like a clear separation of concern, just-in-time evaluation only during scheduling. The states are not messed or or like affected elsewhere. That's what I've been thinking. Having this as like a filter condition plugin. Another option that also evaluated is like a node controller managing the state explicitly. When I say state, like having a specific taint could be one of the options that could represent like readiness gate is pending, and existing taint toleration scheduling plugin would have the scheduling control naturally handled. This has some cons. Of course, with addition of multiple components in between, there is some latency increasing between the status update and the derived state, like scheduling is ready or not. That is not desirable, and also we would be overloading taint with this other mechanism, which I think that is not necessary. The previous approach with having a scheduler filter would also enable clear migration for nodes. So I think that's the preferred option, but happy to discuss this further. I think like I could take a stop here. I think benefits we already discussed and talked about. I could go to the walkthrough real quick and capture how this will look like.
Jay, we already spent 36 minutes on it. We still have 2 minutes on this. So let's listen for these 2 hands, and then we can switch the topic.
Sounds good. Okay.
Yeah, on that note, I feel like the scope of this is getting to the point where it almost maybe warrants a working group. I don't know if like, having these conversations at SIG Node will be enough considering all of the different stakeholders here and all of the complexities. Would you be interested in sort of trying to pull something like that together?
Sure, I think I could follow up on that. The different six who would be interested in the, depending on what all we try to address, I think like we could discuss on creating a working group.
Yeah, I was going to say, we can talk about this in Node Lifecycle. The new working group we're starting, this is actually one of the topics that we had in mind. So I'm actually glad that you started thinking about this and people started talking about it. So I think that would actually be the perfect place to continue the discussion.
Thanks, Ryan. I'll discuss further with you on this offline.
Should we then bring like the node capabilities discussion in there too? Because it seems like it's overlapping. Like it's a more static thing as opposed to readiness, which is like an initialization thing, but they're essentially very similar concepts. So Praveen, yeah, okay. Okay.
Yeah.
Okay, Jay, next topic is still yours. Eviction hard.
Yeah, I think that like I wanted to bring attention to this. There is already discussion on this. The idea is that like when let me just like open that real quick. When a node is already configured with a sysctl parameter, like declaring how much kernel memory should be free on the node, I think that like it is desirable for the eviction threshold to be over that limit, because when that minimum free kernel bytes is disturbed, it would early trigger the killer on the node. I think preferably that like Kubernetes should have the eviction handled as per the user-defined priority and the many things like we want it to be, like Kubernetes native, like for example, like gracefully shutting down the pods rather than killer killing the containers directly. That was a proposal on this. I think I could. I want to bring attention to this, but happy to discuss this offline on the issue.
There's already discussion GitHub issue that you posted. Can you summarize it or?
Yeah, I could summarize that. Let me also share the screen quick on this. So this is, I think I hope my screen is visible. This is for the min 3 kilobytes sysctl parameter. There are other references as I found offline suggesting this to be over 1 gigabytes. We define the threshold to be 100 megabytes, so that like eviction threshold by default would try to maintain only 100 megabytes on the node, and it would start eviction after that. However, Linux kernel sets the limit dynamically for larger RAM. It would be like a different megabytes. For example, for a 64 gigabytes RAM, it would be like 256 MB. We don't consider that like the node could have different different kernel bytes. So we are not actually having eviction working on many of the node categories. So this is my observation. And also this is critical for swap, because like when we want to improve or like have an increased swappability on the node, likely we could have a control by having this minimum 3 kilobytes to a larger setting that would influence like early swap start to be able to like have the memory to be offloaded to the disk or swapped to the disk, rather than like going to a direct reclaim where it would terminate with a boom killer. So if you want to have that better protection from boom killer and better swap utilization, it is preferable to have this eviction threshold more of a dynamic setting rather than having like a static limit like 100 megabyte. What I propose is to have like a dynamic range where we would check what the sysctl value is and have like a safety margin like a 10% on that, so that like we have buffer for like kernel to reclaim the memory or like Kubernetes get some buffer retained before it can signal own killer. That's my proposal. There are some I think that like disadvantages or drawbacks on this as well. First is that like we are expecting these sysctl to be readable on a I think that like user namespace driven kubelet is running situation. This may not be readable. I think in those cases we could still use the default static limit. That's my overall thoughts on this. Open for discussion.
Just to be sure I understand, you suggest to change the default logic calculation, but customer can still override to whatever values they want.
Of course, yes, we should still have a user override. The reason being that like if the user intent is still not to use kubelet based eviction, they have like maybe better memory management control, or they have like different mechanism to follow this. They should still be able to do that. If they don't want to have kubelet eviction, they can still be able to override eviction threshold. We shouldn't be restricting on that.
I mean, we don't set kube reserved and system reserved automatically to the correct values. I don't see super big need to change the default calculation. People can override it, and maybe it's a documentation bug that we need to fix.
I think is that like by default protection, what Kubernetes offers should be to be better for the node protection. For example, if it is like a high memory or a fast rate growing workload, if it is like a default, let's say like 66 MB, like reserved kernel bytes, and eviction starts at 100 MB, it may not be able to recapture the memory to protect the node. Like this would influence node stability in the future. I think like that's what we should focus on. I think just having a documentation bug can be overlooked. Could be best practice, but if user explicitly wants to protect some memory, we also want to make sure that like kubelet level protection is also there. So I think it could be a better alternative than just having like a documentation report.
Yeah, my point is we don't set kube reserved to the default value, and kube reserved already is also like affecting node stability. I wonder if like, and also like what kind of environments do we need to consider? Like, do we need to make sure that it's stable on Raspberry Pi? Or, like, do we need to consider it stable on like super small devices, like super big devices? I don't know. Like, I don't feel really strongly about like not letting it in, but I don't see a huge need for doing this work.
I think for like a small device,
let's make a new commitment on default configuration stability and like go through all the settings, not just this one.
I hear point. I think my point is to not have the like a different default. My point is to have it like a dynamic default. If it is like a small node, it would have like the still kernel setting appropriate for that node, having like a 10% above than having like a default 100 would still be addressing the small size of the node, I think.
So if we fail to read it or we read it incorrectly, do we have some protection in place? Do we make sure, like, do we need to make sure that we like delay Kubernetes start before we can calculate this default? All these questions are coming to mind, and I don't know like how important it is to protect stability or protect eviction hard stability versus just make it configurable and customer can do whatever they want.
I think configure and let user can determine whatever they want. I think like it's already there. It's not like replacing that. But yeah, like happy to discuss those points further on the issue. I hear their concerns on like where all it would really be needed and how it affects node stability. I think I could take that feedback and continue on the issue.
Yeah, I was going to say I can see this being very useful in the swap use case, just because, like, I imagine a lot more of this information becomes more important for swap, which is kind of complicated to configure this before the ohm killer steps in. But I also kind of agree with Sergey. I don't know if the need is that strong for this one at the moment. The other thing is when you're neglecting the calculation for Windows. So like it would be clear, maybe clear, like for these values, we want to have to think about a little bit more about how to calculate these for different OSs, because this is a setting that Windows does use also.
Thanks for bringing up the Windows direction. I could take a look at that. Yeah, my intent is to primarily on the, also on the swappability. When we want Kubernetes customers, if Kubernetes customers want to protect the system by having an early swap, I think that like this would be giving more window of swapping opportunity for the workloads. Like so, changing this parameter would be more like it can be expected more now with swap than before. In that case, the kubelet eviction should still be giving a layer of protection, not just assuming just 100 MB is the static limit. But yeah, like I think like I could gather the feedback on Windows and how it would look like on small pod nodes and where it would really be needed, and we could continue this discussion.
Okay. Next topic is Samuka. Are you on the call?
Hey. Yeah, I'm on the call. Yeah, I just need a review on this particular PR. I can give a quick summary on what changes we are making. So right now, like if you check the node lifecycle controller, like it pauses like all pod evictions, like if a zone goes unhealthy. So if it meets the large cluster threshold, whatever it is set to, so greater than that particular number, it stops all the evictions, but it resumes the evictions if it is like if we are back, like if all nodes in a zone goes unhealthy at the same time. So during a full, that means the node lifecycle controller marks it as a full zonal disruption. In this case, like it re-swaps the QPS function to healthy QPS, resuming the eviction on the nodes. So this PR is to just address, it's like a knob, can turn it on and off to pause evictions in case of a full zonal disruption. I'd like to understand if you guys have any thoughts. Anything? Any questions? Any concerns?
So node, we could do that, but the problem is, I think that's not a node, right? So you need to have to reliably detect that wrong disruption, the intent of the wrong. You can, this one actually, I've been raised to the, okay, which team? There's no such team, control plane team in the past, the architecture teams. So how we reliably detect of the network partition, right? So it's kind of similar problem. If there's the network partition, and do I need the journal? We don't have that one. So this is not the node problem, right? So on this kind of thing, node will be always serving native the workload running as running until the things it is actually is on the controller side. They say, oh, node is disconnected for 5 minutes, right? A little bit more than 5 minutes. Don't receive anything. They assume it just node die. They don't think about there's a network partition. They don't think about some temporary disruption, wrong disruption, all those kind of things. So then they just brutally reschedule those parts, right? So then when even like the network is re-established, and because you don't want to duplicate those kind of things, so you have to remove. So this problem actually has been repeatedly raised many, many times. But the problem is, here is the complexity. Okay, we could build that mechanism, but the complexity it is the open source is we can build those kind of things into. But the open source, there's no either way for us to detect there's the network partition, right? Network partition that goes to each vendor, and in their backbone network, there's complicated things. So they need to detect that. But then there's the mechanism to just say, oh, let's just do what? That's the problem. So I just want to say that this is not no problem, and we already do our best. Even this word is not perfect, but we do our best to make everything's working. And then later, when control plane see our node, and then say, okay, those part is useless. That's kind of things today's word.
So I was questioning the node lifecycle behavior itself. I mean, if this doesn't belong in SIG node, I can take it to where it actually belongs. But like since we already mark those nodes to get evicted during partial zonal disruption, like why is there a behavior change during full zonal disruption? I understand that we might not be able to create more capacity if a zone is down. So that might be the case where we want to evict all the pods so that if we have capacity in the healthy zones, the pod has a place to go to. But I think we should have a knob to control, like if those pods are to be evicted or not during full zonal disruption.
Node knows global knowledge. Even node come back, node say, oh, there's the capacity other place my pod can go. If node can be that one, node is already be control plane node, right?
Yep.
So even control plane node don't know. Only the control plane pods running on node will know. So nobody have that. At least the node don't have that global knowledge. So this is why there's no way for us to know. There's the other, right? So unless the somewhere off band to tell us remove something or whatever, right? So that's why this is not the right approach on node take care. I also so yeah, it's unclean architecture to do this. Yeah.
So you think that we should continue to evict pods, like if all nodes go down in the same.
So this is why we could improve of the control plane, right? So those kind of things instant, like immediate, there's the gradually or not. See, there's the trade-off, right? So trade-off, what's the percentage? How quickly, how concurrently you want to run, right? So you could just don't run immediately everything, right? So
this is in the control plane itself. Sorry if I was not being clear. So this is in the node lifecycle manager. So this the eviction is by the node lifecycle manager.
Okay. Even like node lifecycle management, we could change. We can build those logic, of course. Yeah, of course we can build those knowledge. Yes.
All right. So then, do you mind? So the next step here is to just for the PRs to be reviewed. Do you mind taking a look?
Depending on the size of a change, it may need to go through cap review. Because there may be some concerns about backward compatibility, rollout stages, and stuff like that. So yeah, if it's a big change in logic, it needs to go through the cap review.
All right. Yeah, I'm gonna add this. All right, we can take it up in the PR review. Thank you.
We definitely talk about it. Let's at the cut planning, put this into planning and prioritize this one. And please start with CAP. We want to understand the new proposed node state change, right? So this impose another condition, and we should consider. But you are right. If it's node life cycle controller, we definitely should have this knowledge. Then we can handle better. But we need a signal. Node life cycle don't have that signal. This is the full room disruption or not, right? So just like the previous, I mean, we don't know this is a network disruption. Network.
Yeah. But even for the signal, we need to understand whether all the vendors will be able to expose those signals, and yeah, it needs to go through some review process.
Yeah.
CAP is the best process for this.
Good. But this is required. This is good things to work on. Right. I just want to comment. I don't want to discourage you. This is good things we should address together. Yeah.
All right, I'll put up a proposal and we can take it from there. All right, thank you so much. Yep.
Yeah, unfortunately, we reached almost the end of the meeting, and we still have 2 topics. I suggest we move them to the next time. Sorry about it, and thank you, everybody. Have a great rest of the day.